I hope that we have our Woo Club. Remember, I told you about Woo Club. So you can just open in your phone. While you're still in the meeting on Zoom, we're going to be using Woo Club in real time. So you can just go to your browser as well and open the Woo Club. It's really going to help us. Okay, so climate change from learning to action. The goal of this course is going to simply give an introduction to what is climate change. We hear today people speaking about climate change. Now we even have a ministry, that's dealing with climate change specifically for that. And there's a reason. It's because climate change has become a serious problem. It has become something that's on every media, every media platform, on the news. Climate change, climate change, climate change. And so what we're seeking to do is to be able to learn what is climate change all about, what can we do, how does it affect us, and away from just the theoretical parts, to actually put it in action with some of the activities that we're going to have later on. And so what is climate change? This is the first module today. Like I said, we're going to have 6 modules, and this is the first one. So today we're going to look at what is climate change, basically. And after completing this lesson, the objectives are that you should be able, at least in your own words, to explain what climate change is, to a young person, again, because it's Children Development and Empowerment Foundation. So we deal mostly with young children, with teenagers, but even to our own peers, to be able to explain, to be able to discuss how human activities affect the climate, to be able to explain and observe some of the projected trends in climate and also different climate change scenarios. And we're going to look at all these things. And so in this module, which is today, we are going to have 3 basic lessons. It's divided in 3 parts. Number 1, how does the climate system work? Number 2, what are the observed and projected changes in climate change? And number 3, what are the effects of climate change? So let me just share my screen again. Okay, so let's begin this. How does the climate system work? Again, just make sure if you want to say something, you can write it in the chat, or you can stop me in case I don't see the chat. Okay, so how does the climate system work? Here, what we want to do in this first part is to explain what is the difference between weather and climate. These are basic definitions we'll look at, and we're going to describe the climate change system and the main drivers of climate change, meaning the main causes. And then we're going to identify the steps and elements of what is called the carbon cycle, which is a very important concept when we talk about climate change. And so let's start here. This is a reflection looking at weather and climate, okay? Very often people confuse these words. People use climate and weather interchangeably, but these are very different words, especially when we speak about climate change. And so listen to some of, or read some of these phrases with me. Number 1, climate is what we expect, weather is what we get. These are just some illustrations. We're going to get to the actual definition of it. So climate is what we expect and weather is what we get. Or somebody would say weather is one football game, football league. Are you getting the differences there? Somebody else would say climate tells you what clothes to buy, weather tells you what clothes to wear. Now, before we look at what climate actually is, the actual definition, I would like to hear from you. What do you think is the difference between climate and weather? What do you think is the difference between climate and weather? Just feel free to open your mic. What do you think is the difference between climate and weather? What comes to your mind? Any idea that comes to your mind? Climate and weather. If somebody said, tomorrow in Zambia, we're going to have snow, or maybe we're going to have extreme heat. Okay. And if you saw on the news, somebody says 2021 is the hottest year ever. Which one of these would scare you, or which one of these would raise a concern to you?
Okay, what would raise a concern is the fact that it's gonna be very hot. Not like 2021 is gonna be, for me personally, it's gonna be a very hot year because I don't know to how much hotness it's gonna be. Yeah.
Okay. Awesome. So if somebody asks, maybe let's say one newscaster today tells you tomorrow is going to be, it's going to rain extremely, it's going to rain so much. And then somebody else maybe says 2021 is going to be a very cold year. Or which one of those would scare you the most between the two?
I think because we're prone to think of tomorrow before thinking of the future. I think we're most likely to be worried about tomorrow than 2030 or later on.
Exactly. And you've also said, I've always thought weather is a smaller portion of climate as a whole. And so it is very true that most of us are much more concerned with the weather. And even in this very picture, you can sort of see where we are going. You can sort of see what the difference between weather and climate is. When we speak of weather, we are talking about a short-term, the short-term statistics, or the short-term state of the environment, or the atmosphere or the environment. But then when we talk about climate, we're talking about long-term. Let's look at the actual definition according to the World Meteorological Organization. This is WMO, uh, which actually it's the World Organization that is tasked with the responsibility to gather information, meteorological information. Meteorological simply comes from the word to measure. So they measure things like temperature, they measure things, everything that has to do with the weather and has to do with the climate. Now, they define climate in this way. They say climate in a narrow sense is usually defined as the average weather, or more rigorously as the statistical description of relevant quantities over a long period of time, ranging from months to thousands or millions of years. So basically what this is saying is that you can simply define climate as average weather. So just the way was it Usuma who said weather is sort of like a small portion of climate. That is very true. Weather over a long period of time is what we use to classify the climate. And so if you look at the second part of this definition, where it says statistical description in terms of the mean. If you remember the mean, how we used to calculate, you might remember from your mathematics, the mode, the median and things like that. The mean would be you add up all the numbers and you divide by the number of numbers, right, to give you the average. This is exactly what is done. This is exactly what the difference is between weather and climate. And so if we say tomorrow it's going to be extremely cold or it's going to be extremely hot, that doesn't mean climate. We're talking about weather. That is a weather forecast. But when we say a period of 6 months or a period of a year or thousands of years, long time periods, what is going to be the average temperature? What's going to be the average rainfall? The average weather? Then we are speaking about climate. Okay, so I hope that difference is clear. Now let's go to WooClap now. Let's head over to WooClap on your phone, and there's a couple of interesting questions. Let's just see. Don't worry, WooClap doesn't show who has answered or what, so it's not a problem whether it's wrong or anything. So let's go to WooClap. I'm going to give you a link. Okay. Let's follow this link. You can go to WooClap and just type the code HZAKSJ. Okay, and it's going to take you exactly to where you're supposed to be. Okay, so let me know, are you there? Are you there? Okay, let me just post it. HZA. Let me post it. Let me just type it. HZA KSJ. Okay, so we go to WooClap, we put in that code, and then it's going to bring you to this short exercise or this small exercise right here. Welcome to Dan Kashiwa. I'm glad to have you here. I hope that you can hear and everything is okay. So let's go to WooClap and let's try to answer. I'm going to give you a couple of seconds just to answer that question, the question that is there in WooClap. Okay. So the questions are, can you distinguish weather from climate? Very easy question. Can you distinguish weather from climate? It's a simple matching question. So you match what you think, which one you think describes climate and which one you think describes the weather. Okay, and then you just simply match them. Okay, so we have one person who's done it. Let's all head over there and let's have everybody participate. Give you a few more seconds. Okay. Are we having any problems? Are we having any problems with WooClap? If you're having any problems, you can just say. Hello, hello, hello. Okay, that's 2 people. We have 2 more people left. Don't worry too much. It's not an exam or anything. The marks don't count for anything. It's just a tool to help us learn together. Okay, so let's have 2 more people left. 2 more people left. Oh, okay. Welcome, Brian Kashiwa. So what you have to do, what you simply have to go to the link that I've just sent, WooClap. Just go to the link and it will take you exactly to where, to the exercise. Copy this link, Judith and Brian, just copy this link, go to your web browser on your phone and just paste it there. It's going to take you exactly to the exercise and then you just match, answer it. Okay, I'll give you a couple more minutes. Moses, were you able to do it just well? Mr. Dan Kashiwa, were you able to do it just well? Just copy the link. Okay, awesome. So just copy the link, paste it, and see if you're able to distinguish between weather and climate. Between weather and climate. So the first option is saying, it feels hotter than usual right now in Kawe. Kawe, yes, because I come from Kawe. Do you think that is climate or do you think that is weather? And Thailand has high humidity all year round. Do you think that is climate or that is weather? Dry season in Kenya is from June to October. Do you think that is climate or that is weather? Freezing temperatures right now in Mansa for 7 days in a row. Do you think that is weather or climate? Okay, so we have 4 people. That's the majority at least. For the others, you can still answer then afterwards. but hopefully the next time we use WooClap, you already know what to do. So let us see what your answers are. Okay. So it feels hotter than usual right now in Kawe. 5 of you said weather. That is correct. Because why? It is something that is short term. If I say it feels hot right now, then it's short term, right? Thailand has high humidity all year round. That is climate. Okay, that is climate. So 100%. This is amazing. Everyone who participated got it correct. The dry season in Kenya, we're talking about a long period, about a period that has been, studied over time, that it's even established to say from this period to this period, it's always dry. So that is climate. And freezing temperatures right now in Mansa for 7 days in a row. Yes, 7 days, it's a bit of a long time. It's not immediate, but then it is still short time, still a short period when compared to years or months that we usually use when speaking about climate. And so let's go back to our presentation. The climate system is a result of a delicate energy balance. Now we're going into the science of it. Now, don't worry, it's not going to be anything too complex, but then it is just important that you know the basics or the fundamental before we can get to what is practical. So just let me know again if there's any problem, or if there's anything, let me know through the chat, or you can stop me. Now, the climate system that we have, it's a result of a delicate energy balance. Okay, when we talk about energy balance, what I'm saying simply is that we've got energy that's coming into our climate system, and we've got energy that is going out of our climate system. Now, you can imagine that if we have too much energy coming in and very less energy going out, what would happen? It wouldn't be good for the earth. The climate would have too much energy, or it would become too hot. And if the opposite happened as well, if we had too much energy going out and less energy coming in, we would have the opposite problem, where the temperatures would be too cold for us to survive. And so what you can see here on the picture is 4 arrows. The first arrow shows the energy that is coming in, the incoming energy from where the source, which is the sun. The sun is our closest source of energy in the solar system. So we've got energy that's coming in form of light, in form of heat, in form of different kinds of radiation. So we just collectively call them solar radiations, meaning they are coming from the sun. Solar means they're coming from the sun, and radiation simply means they are coming from the sun. Okay, and then we have this arrow here. Let me see if I can use something to point. Let's see. I don't know if okay. Just give me a second here. Okay, so this, I think, I'm hoping you can see my mouse. Can you see my mouse? Give me a minute here. Okay. All right. Anyways, I won't use this. So the second arrow that you see represents outgoing energy, because when this energy comes into the Earth's onto the Earth, most of it is reflected back. So this represents the outgoing energy, the first arrow pointing upwards. And then you've got the second arrow that is within this, that is not going outwards, but it's just sort of pointing to the Earth itself. This is what is called absorbed energy. So this is the energy that comes to the Earth but does not go out. Okay. Now, how does this affect what we are trying to talk about? What causes this climate change? This climate change, it does not happen without a reason. Or what causes changes in this temperature and changes in the climate? It's because of this delicate energy balance. When we have more energy coming in and less going out, then we have a problem. Okay. But what might cause this energy to come in and refuse to go out? That is the question. What might cause this energy to come in and refuse to go out? The first thing is we have got 3 factors generally, okay? And these factors are known as climate forcings. climate forcing simply because they force the climate to act a certain way. Okay. So number one, we have solar variations. Solar variations simply mean that the sun changes its, because the sun isn't constant, right? The sun, the energy produced by the sun, it's not constant. Sometimes it produces more, sometimes it produces less. So if it produces too much, that energy is absorbed by the earth and it cannot, it's leaving at a slower rate than it is entering. Okay. So solar variations, this is something that is physical. It's something that natural that we can't control. The second one is unpredictable volcanic eruptions. Now, volcanic eruptions, why do they cause changes in climate? Well, if you remember on the previous slide, we talked about this energy that remains in the earth. Why does it remain? In a normal case, when this energy comes in, it should go back out. It should be reflected. But then when we have certain kinds of gases in the atmosphere, these gases that we call greenhouse gases, and we'll come to them soon. When we have these gases in the atmosphere, they prevent the energy coming in from going out. And so this energy remains in our atmosphere. And so these unpredictable volcanic eruptions, when they happen, they release a lot of these gases that keep the energy within the atmosphere. Okay, we'll look at what some of these gases are. So that's a second factor that we can't control, because volcanic eruptions, we can't control them. Then the third thing is human activities. Yes, now this is something that we can talk about, and this is something that we'll focus on because it's something that we can control. Human activities as well, again, where do they act? They act on the same gases that have the capacity to hold energy, to stop the energy from going out, you know? And so these are the human activities that are a major cause of the changes in climate, the changes in the average weather, okay, over a long period of time. Now, the climate system itself, okay, is, and this, I know this is like a lot of theoretical stuff, but don't worry, we'll get to the good stuff very soon once we just have all of this out of the way, okay? I'll definitely share the slides. Again, if you have anything to say or anything to comment, to ask, you can use the chat or you can just stop me. Now, the climate system, right? It's made up of 4 major parts. The first one is the geosphere. Now, remember, all these things we're talking about, they have a relationship with the climate and with climate change. The key source in this system, as you know, a system should have inputs and outputs. A system should have something coming in and something going out. So the key source of energy is the sun. We have already seen that. Then we've got the first part, which is called the geosphere. Sphere simply means, you can think of it as area. So these are just fancy words that scientists come up with. But then sphere simply means, you know, an area or an environment. And then geo is the word that means earth. So when you talk of geosphere, we're talking about rocks and we're talking about soils. And why are they important in the climate system? Because rocks and soils, they store carbon. Okay, carbon, again, we're going to see is something that has got a major effect on the climate system. So you see why this is going. But geosphere as well, the geosphere, meaning the rocks and the soils, they're the ones which also store fuels. When you think of petrol, you think of diesel, you think of natural gas, these things that people mine, these are found in the geosphere. And the fact that we are removing them is one of the reasons why we have these changes in the climate, because they produce gases, again, that are able to stop the energy from going out. And so the geosphere has got a huge role to play in this. We've got the atmosphere. We all know the atmosphere. It is the area between the earth and outer space. So in the atmosphere, what is interesting about it? We have greenhouse gases. Greenhouse gases simply refer to gases that are able to stop the energy from going out. Gases that are able to absorb the energy that the sun brings in. That in a normal case should be reflected back out. And so what are some examples? You would be surprised to know that actually the greatest greenhouse gas is not carbon dioxide. It's actually water vapor. Water vapor is the greatest greenhouse gas. The more water vapor there is, the more heat there is. And then the second one is methane. Methane. The third one is carbon dioxide. I'm sure we all know carbon dioxide. And then you've got several other gases like aerosols. These are gases or chemicals that are used in perfumes and other things like that. But methane, let me ask this question. Where does anybody know where methane comes from, or what produces methane the most? If you've heard of methane, just take a guess. Take a guess. Anyone? Come on, guys, you need to be participating. Methane, where do you think methane comes from? Methane? Hello, are we together? There are no wrong answers. Don't think too much. Where do you think methane comes from? From the laboratory?
From the atmosphere.
Okay, yes, that's very that's very true. Brian, you had to say something?
Yes, methane is highly produced during the manufacturing and production, and as well as transportation of natural gas. Natural gas, during those processes in which they are produced as well as transferred, there is a byproduct methane that is produced in one of those, as well as during fermentation of different substances, methane is a byproduct gas that is produced.
Okay, awesome, amazing answers. So I think, was it Mwansa who spoke first? You said in the atmosphere. So yes, even though it's not produced in the atmosphere, it's present in the atmosphere. So you're very correct in that. Judith, you also say it's produced in laboratories. Yes, obviously, people who study these things, they make these chemicals in laboratories. Thank you so much, Brian, as well, for that answer, where you say in the production, in industries, methane is produced as a byproduct. And methane is also a very dangerous, it's a kind of a gas that has a huge capacity to hold a lot of energy, and so it's able to capture a lot of the energy that is coming through from the sun. And Dan also says decomposition of waste organic matter. That's a very interesting answer, because you will find that, again, amongst the major producers of methane is actually cows. So cows are actually one of the major producers of methane through their farts. When a cow farts, the majority of what's in the fat is methane. Okay, it's methane. And this is the reason why the beef industry has got a major footprint on the climate, on the change in climate. Why? Because the bigger the beef industry is, the more the cows that you have. Somebody talked about transport. It means the more transport that is there for you to be able to move beef from this area to export. So you've got a lot of what we call a carbon footprint, a huge carbon footprint on just the beef industry itself. So those of us who like to eat beef, I'm not saying anything, but anyways, we've got the hydrosphere as well. Hydrosphere has to do obviously with water. Dark waters usually absorb a lot of light and heat, solar radiation, while you've got light waters and you've got ice that reflects that water back. So you find like the North Pole and the South Pole, where there's a lot of ice, most of the heat is reflected back there. That's one of the reasons why those regions are very cold, because most of the heat is reflected back. Not the only reason, but one of them. And dark waters absorb a lot of light and heat. And then you've got the biosphere, which is you and I. Bio meaning life, plants and animals. Through the respiratory and photosynthetic processes, we also contribute to the change in climate. Why? Because we breathe in oxygen, we take out carbon dioxide, and we've just learned that carbon dioxide is one of the greenhouse gases. And then you've got trees as well that take this carbon dioxide, that's a greenhouse gas, and gives us oxygen, which is not a greenhouse gas. And this is the reason, this is one of the motivations behind everything that we are doing, because as you know, we're going to have a tree planting exercise. And all of that is to do what? To be able to promote an awareness in people to say, the more trees that we plant, the more oxygen can get into the atmosphere, and the less carbon dioxide is there, meaning the less greenhouse gases, meaning the less heat is trapped in the atmosphere of the earth. So this is basically the climate system. And so everything on our planet is connected. Every rock, every plant, every drop of water, every person, every living being, every plant is affected and is being affected by the Earth's climate. Okay, there are certain people who say this has got nothing to do with me. This has got everything to do with you, because we are all affected. And we're going to come and see what some of the effects actually are. And so I'm going to send you this presentation. I've added more resources here. This is simply a short video that's going to summarize what we've talked about. So that was lesson 1. What is climate change? Don't worry, this one isn't as long. But lesson number 2, or the second part, is what are the observed and projected changes in climate? Now, what do we want to get from here? We want to identify the main global climate indicators. We keep saying climate is changing, climate is changing. What things can we look at to indicate that the climate is actually changing? We can't just be saying, no, I hope we understand some Bemba in Nyanja. At yo akasubale kuleka sana, yo kuleta rara sana. No, the climate is changing. What are some of the indicators? So we're going to look at those. And then we're going to discuss the direct observed changes of climate indicators. So now, once we know what the indicators are, we'll try and look at how are they changing and how does that relate to the climate changing. And then we're going to have thirdly, we're going to discuss a bit on projected changes of climate indicators. So let's get into it. Climate indicators. Now, this kind of information, again, is found mostly in the World Meteorological Organization. This is an organization, again, that is tasked with the responsibility to measure and to keep records of these indicators. So number 1, we've got the global temperatures. Obviously, we'll talk about global warming, right? So global warming and climate change are not the same thing. Global warming is a symptom of climate change. It is something that is under climate change, but they are not the same. Usually people like to use these things interchangeably. Climate change involves more than just global temperatures. And so the first indicator, what is it that scientists look at to indicate on the state of the climate? It's the global temperatures. What is the average temperature? Okay. And then the second thing they look at is greenhouse gases, the concentration of greenhouse gases. Concentration simply means the amount of that particular material or the amount of that matter in a given volume. So in the volume of the earth, the amount of matter that is present there, the amount of greenhouse gases that is present there. Somebody wanted to say something. I heard that somebody opened their mic. Okay. So the third thing is the precipitation, right? The precipitation is basically rainfall. Now, precipitation is a bit difficult to measure. Okay, it's a bit difficult to measure, and measurements on it haven't been done very much, and so they don't usually use it as an indicator. But it's also one of the things that can show us differences in how the water or in how much rainfall we are receiving. Okay, in a given period. And then we've got ocean heat. Now, this is a really important one. You see when we talk about it. And we've got sea ice, and we've got the sea level rise. So ocean heat, I told you that oceans absorb the most of the thermal heat, thermal energy. Thermal energy is heat, right? Most of the heat that comes into the earth. And so imagine if there were no oceans. If there were no oceans and there were no oceans to absorb the heat, the earth would be exactly the way Venus is. It would have the temperature of Venus. Okay, you know, Venus is the second closest planet from the sun. All of this just to say it would be very hot, okay? And then the more that the oceans heat up, the ice also begins to melt. Now, already you know that there's thermal expansion, meaning hot things become big, right? And cold things become small. So if the oceans heat up, it means they also become big. They occupy a larger space. And if they do that, the ice also begins to melt. So now you've got another indicator, which is how much sea ice is there. So we can use how much sea ice is there to indicate or to tell us on the state of the climate. And finally, we've got the sea level rise, meaning how much in terms of length, in terms of milliliters, or in terms of centimeters, how much has the sea risen? Okay, so let's go to WooClap again. This one is going to be a hard question. This one is going to be difficult. So let's go to WooClap, and the link that we're going to use this time, I'm about to send it. So let's go to WooClap. Go to WooClap. And we're going to have let's see what some of the thoughts will be on this. Okay, I've just posted the link. So go to WooClap, you've got YFFIGB. Or if you're already on WooClap, you can just write there where it's written code YFFIGB. Okay, so let's go to WooClap and let's try and answer the question that is there. Let's try and answer the question that is there. Okay. Now, the question is, which one of these is not a global climate indicator? Which one of these is not a global climate indicator? Okay, let's try. This one is going to be difficult. Take a few seconds to think about it. Which one of these is not a global climate indicator? Which one of these is not a global climate indicator? Follow the link. And follow the link, and let's see. Don't just see what your friends are answering and then you follow them. So, feel free to choose what you think. What do you think is, which one of these do you think is not global climate indeed? Okay, one more person. Vosoma, you wanted to say something?
Sorry, no, I got logged out. I was just logging back in.
Okay. Okay, so 5 people have participated. Amazing. Let's check out some of the answers. If you don't know how to participate, just follow the link that I have sent. Let me resend it. Copy this link, paste it in your browser, and just answer the question. So which one of these is not a global climate indicator? The majority have said ocean acidification, okay, which is 2 people. Somebody said precipitation, which is rainfall. Somebody said sea level rise, which is how the sea is rising, of course. And then you've got the sea ice. Okay, so the correct answer is actually nobody chose this one. The correct answer is actually all of the above are global climate indicators. I did not mention ocean acidification just to trick you guys, but global ocean acidification is another it's another global climate indicator. How? What happens is this: once the amount of carbon dioxide increases in the atmosphere, it begins to dissolve into the oceans as well. Now, you know that, oceans usually have a lot of salt, a lot of sodium chloride. I'm not a chemist. Some of you have studied biology and chemistry. I'm not an expert on this, but I know that the carbon dioxide begins to dissolve with some of the salts and some of the chemicals that are there in the ocean, and that leads to acidification. So the oceans become acidified, and already I'm sure you can see that there would be major problems with the oceans becoming more and more acidic. And how would we measure that? Obviously, we would use pH. If you remember, some of you from your chemistry, we've got pH, which is a measure of how acidic something is. And so scientists, they also use that to determine how much the climate is changing by measuring how much the oceans are acidic. Okay, so let's move on. Are you able to see my screen? Okay, so we have been tracking the global climate indicators for a fairly long time. Okay, these scientists, people who study climate, they have been looking at the data from the early 1800s. Why the early 1800s? The early 1800s is when the Industrial Revolution began. So this is when the use of petrol, the use of diesel, the use of all these things that cause pollution and that cause that produce greenhouse gases. This is the period when it sort of spiked. Okay, like it just exploded, and so they use this as a standard. They say, what were the temperatures, or what were the statistics before this industrial revolution, and what are the statistics now after this industrial revolution? So you've got number one, the global temperatures. Okay, don't worry too much about the figures. It's not important that you memorize them, but just to sort of understand and see the trend. Okay, so you've got this is a graph that is showing, you can see from the 1850 how it has been warming. Okay, so you can see towards the 2000s, the 1970s. Now this is the advent of technology, the advent of power plants, power stations using a lot of coal. This is the advent of vehicles, aeroplanes, transportation, sophisticated agricultural systems. This is the period. So global temperatures, okay? And then you've got greenhouse gases that we spoke about. Now you can see that this is an important increase. If you remember some of your mathematics, this is the gradient. You can see that the gradient, or what was it called again? The slope is, greater than zero. So it's increasing. And then you've got, this is in parts per million. Okay, so it's basically it's a unit of density, or how much of the substance is there. Okay, and then you've got ocean heat. Now, ocean heat again is a problem, because once the oceans get heated up, ice begins to melt, sea level rises, and you've got fish that are living there. You've got coral reefs that are there. All of these things are affected by the kind of by the heat content of the oceans, okay, and the rivers. And then we've got the sea ice, okay. Again, I'll send you this thing. You can study it in detail, but for now, I just want you to have a visual understanding. So you can see the sea ice. You've got, at the bottom, we've got is it the Antarctica? Yes, so the Antarctica is melting at a very slow rate, but the Arctic, which is at the south part, okay, which is at the northern part of the Earth, is melting the most. And so you can see this one is for the North Pole. Can you see my mouse? Okay, let me see if I can. Okay, now you can see the current thing. Okay, so I'm here when I talk about, let's see, I'm trying to find something that can allow you to see where I'm pointing at. Okay, so Greenland, as you can see, the gradient of this curve is much, much higher than the gradient of this one. So it shows that this one has been melting, the sea ice has been melting at a faster rate than this one. So this, the y-axis here is talking about cumulative mass loss, meaning how much of the mass is being lost per year as a function of time. And same with this one. Okay, you don't need to memorize any of this. It just shows that this one is melting, the ice this side is melting faster than this one this side. Okay, so we're going to move on. Sea level, again, it's a similar thing. So these are different graphs from different institutions, but you can see the general trend. Okay, you can see the general trend that the level is rising. And then you've got also ocean acidity. Okay, you can see that there are certain areas that are becoming more and more acidic as compared to others, you know, and if this becomes acidic, this is a problem, and you're going to see when we get to the effects, which is the last part of our lesson today. And so here's another video that you're going to find the link when I send the PowerPoint. You can just watch it. It summarizes what I have spoken about today. Okay, so far so good. We have got the last part, which is what are the effects of climate change. Let me just know if everything is okay. Are there any questions? Are there any comments, any observations? Feel free to speak. Or at least give me a sign in the chat to say everything's okay. Okay, okay. Thank you. It's encouraging to see the thumbs up. Okay, so we're looking at the last part, which I would say is the most important part now. What are the effects of climate change? What will be the impact, you know, if the climate continues to change the way it's changing? Now, I could start to give you like the figures to say if we increase by this temperature, or if we increase by this sea rise, this is what will happen. But that really isn't the point. Once, if we continue on this, or we're going to actually look at that in a much later lesson. But then for now, we just want to understand, to be able to understand what are these effects, what are the risks involved, okay? And we're going to do this through a way of calculating risk called risk management. Okay, I'm sure some of you also who are studying, some people who are into finance and things, you often talk about risk management and investment and things like that. Well, we also have risk management when it comes to climate change. So there are a few key terms when we talk about climate. There are a few key terms, okay? First of all, we need to know that the climate itself, it affects where species can live, okay? The climate itself, it affects what kind of socio-economic activities can take place. It decides whether this place can have farmers, whether this place can have fishermen, whether this place can have transport, in terms of can have transport infrastructure, you know, so there are all these things, and now you begin to see how it connects to social and economic development, right? And so we've also got the damages and losses in the cases of extreme events. You know, when we speak about extreme events, we're talking about things like earthquakes, things like floods, things like droughts. Those are extreme cases of climate change. So let's take a dive into this. So you've got some key terms here. You've got a hazard, you've got a vulnerability, and you've got exposure. Okay. Now we're going to look at what do these terms mean, and I'm going to use an illustration that I like to use. It's called the desktop flood illustration, right? When you let's take an example of your desk. Imagine that you have a desk filled with several items, right? Imagine it right now. You've got a desk filled with several objects. So let's say you've got your PC there, right? And then you've got your phone, you've got a pen, and you've got a book and some papers, okay? Now, I come and get a bottle of water and I begin to pour it on the desk with all these items there. What would be the hazard? Okay, before I get to that, once I pour that there, you're going to find that all of them are going to face the same problem. So they all have water. The problem is water. But then there are some of those things you have on your desk that are more vulnerable and that will be exposed more. So even though I have a pen and I have my phone and I pour equal amounts of water, the problem, what can I say? The risk that is involved is different, because the same kind of water, if it goes on the pen, I can just wipe my pen and put it out to dry and it's writing okay. But if the same kind of water goes to my phone, there it's different, because my phone, once it dies, one, it is more expensive, so it is a more expensive asset, and it is more vulnerable as compared to a pen to damage, you understand? And so how do we relate all of this? In climate risk, we've got hazards, which is the actual event. The hazard could be the flood, it could be the drought, it could be, it's me pouring the water. But then different things or different assets are vulnerable in different ways. So if a storm happens, but then it happens in the middle of the ocean, okay, that is a huge hazard. But then the vulnerability is less and the exposure is less. Why? Because there is nothing there of interest. And I'm coming to the definitions of this, but for now, I just want you to have like a mental picture, right? And so areas that are urban, let's say the urban areas of Mansa there, the urban areas of Lusaka, Kawe, they have more exposure. Why? Because they have got more expensive assets. If a flood was to happen in Lusaka, the amount of damage it would do would be different if the flood was to happen in a smaller part of Zambia. Let's say, I don't know, I don't want to mention any small part. You say I'm making fun of it. I don't know, but if it were to happen there, you do understand that the exposure and the vulnerability would be different. And so let's talk about maybe sea level rise, okay? If the water begins to rise, for us, it's not a problem in Zambia, because we're going to say, in Zambia, we don't really have a problem. We are landlocked. It's not a huge problem. But think about places like Madagascar. You know, that is an island that is surrounded by water. Once the sea level rises, the people face an ultimate existential crisis. They can no longer continue to exist because water, the island itself becomes submerged. Okay, so think of the people living there. And I'm not talking about things that will happen in the future. I'm speaking about things that are happening now. Think about the Maldives. There's a place called the Maldives, and I have attached a YouTube video to that so that you can watch and just look at some of the effects that this is having now. And so, you know, if we talk about ocean acidification, you've got species in the oceans that are very, very precious and very good, very nice, you know, coral reefs, different kinds of things. But once the ocean, the pH of the ocean begins to tend towards 1, you know, you've got a problem, because those things can no longer exist. And then you've got different kinds of fish. I'm a tiger fish, I'm a bream, tuchsense, all those kinds of fish. And then, you know, for most of those who are based in Mansa, it's fish is a huge part of the economy there. But once the ocean begins to become more and more acidic, it's either those kinds of fish die or they relocate to another place. Now that affects the economic situation there in Mansa. And there are places where this is happening in the extreme, even though maybe you might not feel the effects as much, you know, as Zambia specifically. And you've got temperature, heat waves on human health, heat waves. If you've heard of what is called heat waves, these are I'm speaking of some of the effects, right? So you've got temperature. A heat wave is a sudden increase in the heat, you know. I think it was during 2020. I was in Algeria in 2020. I studied in Algeria, and Algeria, as you might know, has got a huge part of the Sahara Desert is there, and it gets extremely hot. One of the highest recorded temperatures was about 58 degrees, close to 60 degrees, and it was in a town of Algeria called Ouagla. Doesn't really matter the name, but the point is that it was there in Algeria. It was extremely hot. we heard rumors, I can't say I confirmed them, but we heard rumors of people that were dying and that were affected immensely by this heat, you understand. And recently in 2021, in my last year there was forest fires in a city called Tizuzu. And so these were immense fires that just began. They started in the forest and then they just grew due to the dryness and due to the heat. Some people were saying, no, they are enemies of the state who are trying to, to destroy, or who are starting these fires. But whatever the case is, we cannot hide from the fact that climate change was one of the reasons why such things are happening. So many fires. The Amazon was burning just a few years ago, if you remember those things. And so all of these things have got huge impacts on the health system, on the agriculture. Certain crops and certain crops require a certain amount of precipitation and a certain amount of temperature. Anyway, I've dwelt too long on this. Let's go on WooClap. Okay, this is the last WooClap that we are going to look at. Let's go to WooClap. And okay, let's go to WooClap. And this time we're going to try and match the definitions. We're going to try and match the definitions. Okay, WooClap, where is it? All right, here. So this time, we're going to try and match the definitions of what we've just spoken about. Here's the link, copy, and I'll paste it. Okay. I know we've taken a little bit longer than expected today. Maybe it's just because it's the first time, but we're almost at the end. So here's the link. Here's the link. Let's go to WooClap and try and answer this question. This one is also a very hard question. So take a few seconds to think about it. Okay. So there is the code. Just copy that, paste it in your browser, and try and answer the question. Okay, let me share the link again. Let me share the link again. Okay, there it is. Copy the link, paste it in your browser, and let's see. Okay, copy the link, paste it in your browser, and so take a few seconds, think about it. We talked about hazards, vulnerability, exposure, climate risk. I didn't give you the definitions, but we'll give them to you after this. Okay. So match the definitions of the key concepts below. Match the definitions of the key concepts below. A hazard, a vulnerability, exposure, and climate risk. This one is a hard question, this one. Okay. No one has answered yet. Go ahead, go ahead, go ahead, go ahead. Do we have a problem with the link? Is there a problem with the link? So just copy the link, paste it in your browser, and then match them. Which one to which one? Okay, we have two people. Okay, everyone is done. So we have 4 out of 4 people. Which are some people, there's some people I've noticed who are joining, leaving, joining. Maybe it might be the network. But okay, no problem. Is there anyone facing a problem with WooClap? If there's any problem, let me know. Okay, so match the definitions of the key concepts below. Let's see what majority of you have said. So almost everyone said a hazard. You had something to say, somebody?
I'm quite having a problem with the link. I don't know what's happening. It's failing to load.
Have you copied it and pasted it in your browser? Okay, just copy it, paste it in your browser. Don't worry, even after, if the problem is too much, even after this, you can always answer. So
I've been trying to. Yeah, I've done so. Now it's failing to completely load.
I don't know. That might be a problem with the network, because I can see that about 4 people were able to load it. So maybe it's just a problem with your network or something. Or maybe because you're using Zoom, so the network is already a bit slow. You can still try it afterwards. So yeah, let's look at the definitions. So a hazard, the majority of you said, is a natural or human-induced physical events that may have adverse effects on systems. That's correct. So the hazard can be, like in our example, the bottle of water. And then you've got vulnerability, climate risk. Most of you say the function of hazards, exposure, and vulnerability. And then 3 of you, so here, that's why there was a problem. Okay. So one person said, okay, let's just look at the correct answers. So everybody got hazard correct. That's great. Everybody got climate risk correct. That's great. Vulnerability. I knew this one was going to be a bit tricky. But vulnerability is the presence of human and natural assets in places where hazards may occur. So when we say that this country is vulnerable, or this district is vulnerable, this country is vulnerable, we are saying that this country is in a place that, you know, through experience, we know that hazards may occur. There's a higher probability of hazards occurring. So you look like at a country like Japan, for example, that usually experiences like so many earthquakes. You know, it is at a higher vulnerability as compared to us as Zambia. Okay, and then when you look at let's see, what am I saying? Oh, I've actually exchanged. So vulnerability, the extent to which exposed assets can suffer adverse impacts when affected by hazards. Okay, so vulnerability, I'm sorry, I confused the two. I was reading exposure. So vulnerability, again, it's the extent to which the exposed assets can suffer impacts. So the asset, for example, in the example I gave was the PC and the what's this? The pen. Both of them have suffered the same hazard. I've poured water, but one of them is more vulnerable. Why? Because the extent to which my PC can suffer is more than the extent to which my pen can suffer when affected by the hazard, which is water. And then the exposure, of course, is just the presence of human and natural assets in places where the hazards are okay. So this is now where the example of Japan and Zambia comes in to say Japan is more exposed. It has got a higher level of exposure as compared to Zambia, simply because by probability, there are more of these hazards may occur there. So these are just, you know, terms that can be a bit funny, but then I'm glad that most of you, majority of you got everything correct. Okay, so let's try to conclude this. let's try to conclude this. Let me share my screen again. I'm using one PC, so I have to share my screen whenever I change screens. Okay, let's see. Okay, so we're talking about climate risk. And the point that I was trying to drive in all of this is that climate risk is a function of hazards, exposure, and vulnerability. When we want to know what is the risk that what is the risk that we're involved in, you have to look at how much of our assets are exposed. So if you're in building, if it's engineers who do building, civil engineers, they are looking at these buildings that we're creating. How can we build them in such a way that they are less vulnerable to changes in climate? Okay, they are less vulnerable, so that even when the hazard is big, since the vulnerability is small, the climate risk also reduces. If you understand, you think of it like a mathematical function, right? Like a mathematical function where you have let me write this down. I like to, I'm a huge fan of mathematics and stuff. Okay, so think of it as climate risk is equal to a function of, this is a bracket, a function of the vulnerability, the exposure. Can you guys see what I'm writing? It's not the best handwriting, but I think you see what I'm trying to do here. And hazards, okay? And so if the vulnerability increases, the climate risk also increases. But if the hazard reduces, even though the vulnerability is high, the climate risk is still low. And this is the case where I think as Zambia we are. And this is the reason why maybe we might feel safe. Our vulnerability is high. If you look at the kind of infrastructure that we have, you look at the kind of transport system we have, you look at the kind of agricultural system, irrigation systems that we have, the vulnerability is very high, but the hazards is low and the exposure is low. And so our climate risk is low because, we're not exposed to as much, and the hazards that hit us are not as bad, but our vulnerability is still high as a country. And this is, a call for those of you in different sectors, those of you who are in finance. I'm saying finance because they're the ones that I've met people in finance, because you look at how can we finance climate change. That's also another topic altogether. Those of you who are in building, those of you who are in different things, this is something that we can start to work on as Zambian youths. And then, so yeah, here's another example. Let me just read. Okay, exposure, severity, frequency of climate hazards increases the climate or disaster risk. So when we talk about disaster risk, it's the same as climate risk. The IPCC climate, so the IPCC is the Intergovernmental Panel on Climate Change. This is an important international organization that deals with climate change, and we'll look at it at a later time. Here's another example. Cyclones, droughts, floods, heat waves, these are hazards. Exposed assets are road networks, irrigation systems, and livestock. These are exposed assets. Okay. So let's move on to the end. I think one more slide. Okay, so these links, you'll be able to follow them once you receive the PDF. This is our last slide, and this is some food for thought. I just want to remind you that we've talked about three things. What is climate change? So I talked a bit about the science and all of that stuff. What is climate? What is climate change? What are the systems, or what is the climate system composed of, right? And then we spoke about what was the second thing we spoke about? What was the second thing we spoke about? Let's see if you people have been following. The second thing that we spoke about, okay, we talked about some of the changes that are happening and the indicators. So I know you might not be able to remember everything that we've spoken about today, but here are the things that you can at least try to remember or think about. So we have the, share my screen, okay. So we spoke about climate itself, climate change. Think about some of the reasons why scientifically the climate changes, right? And then think about some of the indicators, things that scientists use and weather people, climate people use to look at changes in climate. And then lastly, the effects. The effects, how does this affect us? How does changes in temperature affect different sectors of our living? How do changes in ocean acidity, changes in rainfall patterns affect what we are able to do and how we are able to survive, okay? And with that said and done, we've come to the end of the program of at least I've come to the end of my presentation for today. And I just want you to go home with this food for thought. This is going to be an assignment for you, nothing too difficult. But the food for thought is climate change becoming more extreme? I mean, is the climate becoming more extreme? So think about this. I would like you to write nothing, not more than 100 words in your own opinion, okay? Is the climate becoming more extreme? And number two, can we really do something about climate change? I had a professor once who is very pessimistic. He says, there's nothing you can do about climate change. There's nothing you can do. We just have to continue. A very respected professor actually at my university who used to speak like that. But I want to hear from you as well. Is the climate becoming more extreme? And can we really do something about climate change? Just write a short paragraph, less than 100 words, and express yourself. Otherwise, I've come to the end of my program today. I'm going to open it up for any contributions and for any questions. Judy, if you're saying if we die, we die. Okay, so I would like to hear from you now, guys. I've spoken for a long time. What are some of your thoughts? What are some of any questions? Anything you'd like to bring out? Anything you think I left out? Yeah, Moses.
Yes, for me, I just have a question.
Mm-hmm.
Yes, for the same paragraph you're talking about, both questions should be like the paragraph should answer both questions in less than 100 words.
Yeah. You can just write a few sentences on the questions, your thoughts, your opinions. You can go a little bit over 100. It's not a problem, but anywhere where you're comfortable with. I just want to sort of get your opinions and your views on it.
Okay, all right. Thank you very much.
Okay. Anybody else? Anybody else?
All right, for me, hello?
Yes, Brian, go ahead.
Yes, I think for me, I would just want to emphasize on the need of taking the issue of climate change quite serious, because this is something that affects life on a very big perspective, a very big point of view, and it will really demand a lot that we do our best to make sure that we try as much as possible to combat this issue. The fact that we might not really feel the big impact on it, though we can feel it, but not as much as the generation that are coming are going to feel the impact on climate change. And all this will be thanks to us for destroying the earth. So according to some research and scientists, they are saying we have about 12 years to turn this environmental crisis around. Otherwise, we might reach a point where most of the effort we do will no longer matter. The actions might be unreversible. And you know, we only have one earth and one balance, one solar system, one sun per se. So some of these are more or less of constants, things that cannot be manipulated or changed. They can only be preserved and maintained. So I think this program, despite I'm attending for the first time, but I like it. And I would want us, like, look, we're only 7 attending the meeting. I think that's such a valuable information, just limited to 7 people. I think that's not so okay in my case. I don't know about others, because I feel like Climate change is a topic that should really be every person's interest. So I think if we can expand on our advertisements to make sure that we can try to tackle as many people as we possibly can, I think that would be something very good and something beneficial. Yeah, I think that's what I overall wanted to say. So, let's open up the platform to more and more people, because this is a big issue that will affect all of us, and it will affect the children that most of us will be having. By the time we are 50s, we have children and grandchildren who will be 5. Now imagine them living in a polluted world, a world where pollution has almost become something like a norm. So I think let's advertise as much as possible and open up to possibilities of bringing in new people on board and so on, so that at least next time of this meeting, I would suggest Mr. Ngosa that let's have at least 30-50 people, so that we can spread the news and so on and so forth. That's my contribution on the other hand. Thank you.
Thank you so much, Brian.
Thank
Very
you.
valuable words. Thank you so much, and I think we're definitely going to take that into consideration. Thank you so much for highlighting that. Judith, you have your hand raised.
Yeah, yes, I have my hand raised. I just wanted to really say, like, this has been a very informative session. For me, I swear I was that person who thought weather was climate change. So actually, learning that actually when we talk about climate change, we are looking at the long-term impacts. Then the weather is just small things, basically showing us how the climate, or predicting how the climate is going to be at the long-term thing. And I liked the fact that you linked the fact that you elaborated more to say that actually climate change also has the impact on the social economic thing, yeah, on the food systems as well, on the agriculture, even where people actually, which is making me wonder, which is making me realize why Elon Musk is trying to find ways of making us relocate to Mars.
It might be one of the reasons, yeah.
Yeah, which could be one of the reasons as to why. And yeah, which is so I really enjoyed this session. And like Brian, I said, I hope you people who attended, let's go boost up people in the group so that they also might have the thrill or the joy to want actually to join in next time when we have the session. So thank you very, very much, Mr. Ngosa. It was very informative. And I'll never consider climate change as the weather ever again.
Okay, thank you so much, Judith. Thank you so much. Definitely, let's all try to invite our friends and learn together. Does anybody else have something to say? You can't just go, guys, without saying anything. Anybody else wanted to say something? All right. Okay, so thank you once more. This has taken a little bit longer than expected, but we're definitely going to keep time better. Next week on Friday, we're going to be joined by Nchimunya. Nchimunya is an amazing guy. He's got so many projects on climate that is going on. Just yesterday, I was seeing pictures of him with the Minister of Science and Technology, and he was conducting several things. And so I'm sure you're going to love what he has to share. Okay. And so don't forget, try to do the assignment, and you can type it on WhatsApp, you can type it in Microsoft Word, just add your name there, and then send it to me personally or send it in the group, no problem. And then I'm going to send you as well a quiz, a short quiz on Woo Club. This one you can do from between today and the next session, just to sort of see what you have gotten and what you haven't gotten. Otherwise, for me, that's it for today. Thank you so much for joining. Thank you for being on time, and see you next Friday when you'll be joined by Chimunya. Okay, goodbye.